You just got hired at a soda can company, and your boss asks you, which packaging of 12 cans covers more of the base? Packaging A or packaging B? What would you tell them? Let's find out the answer, but first, pause here and make a guess. For both of these configurations, we need to calculate the area of the 12 circles and divide that by the area of the rectangle. For simplicity, let's assume the radius of each circle is 1 inch. Let's start with configuration A. The area of 12 circles is 12 pi r squared, and since the radius is 1 inch, the area of these 12 circles is 12 pi square inches. Now, the width of this rectangle is 4 inches, and the length of this rectangle is 12 inches, since the radius of each circle is 1 inch. So we have 12 pi square inches divided by 48 square inches. And when we simplify, we have pi fourths, which is around 78.5%. So the 12 cans cover around 78.5% of the base. Now let's talk about configuration B. The area of the 12 circles is the same, so we're good there. The length of this rectangle is 13 inches because we have 12 radii and an extra radii right here. And the width of this rectangle takes a little more work. We know the radius of each circle is 1 inch, so we have 2 inches right here. And we need to add this part, and we can find the length of this part by using the Pythagorean theorem. So we have 1 inch over here and 2 inches over here as the hypotenuse. So let's solve for x. And when we do, we see that x is the square root of 3. So the width is 2 plus the square root of 3 inches. So now we have our width and our length. And when we calculate, we see that the 12 cans cover around 77.7% of the base. So for 12 cans, configuration A covers more of the base. So did you get it right? Let me know in the comments. And also, if we add more cans to these two rows, the percent for configuration A stays the same, but the percent for configuration B increases past 78.5%. Do you want to take a guess at what percent this approaches as we add more cans? Let me know in the comments.